Welcome to Astronomy Daily, your go-to podcast for the latest and greatest news from across the cosmos. I'm Anna.
And I'm Avery. We're thrilled to have you join us today as we dive into some truly mind-boggling space stories.
That's right, Avery. We've got a packed episode for you, starting with the discovery of what might just be the biggest black hole ever measured, weighing in at an unimaginable 36 billion times the mass of our own sun.
Plus, we'll journey to Mars with some exciting news about Italy's bold uncrewed mission aboard a SpaceX Starship, and then look even further out to a truly ambitious concept for a 400-year voyage to another star.
And bringing us back to Earth, we'll get the latest on United Launch Alliance's Vulcan rocket as it gears up for a crucial flight, and discuss the bustling future of launch operations at Cape Canaveral.
So strap in because we're about to launch into the daily dose of space news.
All right, let's kick things off with a mind-boggling discovery from about 5 billion light years away. Scientists have just measured what could be the most massive black hole ever found, sitting right at the heart of one of the most massive galaxies on record.
And when we say massive, we mean truly colossal, Anna. This thing has a mass equivalent to 36 billion suns. To put that in perspective, the supermassive black hole at the center of our own Milky Way galaxy, Sagittarius A star, only holds the mass of about 4.15 million suns. It's almost incomprehensible.
It certainly is. This newly measured giant is located in the Tomic Horseshoe system, and what's particularly interesting is that it's a dormant black hole.
Right, which means it's not actively devouring matter from its surroundings, unlike an active black hole that's constantly feasting from an accretion disk, which is usually how we detect them. It's like finding a sleeping leviathan in the cosmic ocean.
Exactly. And the fact that this black hole is in such an enormous galaxy, while Sagittarius A star is in our more modest Milky Way galaxy, is likely no coincidence. Researchers like Thomas Collette from the University of Portsmouth, a study author, believe the size of these supermassive black holes is intimately linked to the size of their parent galaxies.
It makes sense. As galaxies grow, they funnel matter toward their central black holes, which in turn feeds them. This process can also create incredibly bright quasars that actually dump so much energy into their host galaxies that it stops new stars from forming. It's a dynamic, interconnected system.
What's even more fascinating is how they managed to measure this dormant black hole, precisely because it wasn't actively feeding. Normally, it's that commotion, those X-ray emissions that give black holes away and allow us to measure them.
But here they relied on something even more fundamental: gravity. Even dormant black holes have an immense gravitational pull, which warps the fabric of space-time, just as Albert Einstein's theory of general relativity predicts.
Einstein's theory fundamentally changed our understanding of gravity. Instead of an invisible force pulling things, it describes gravity as the curvature of space-time caused by mass. Imagine a bowling ball on a stretched trampoline. It creates a dip, and a smaller marble rolled nearby would fall into that dip. That's a simplified version of how objects with mass warp space-time.
And crucially, this warping doesn't just affect physical matter, it also affects light. The scientists leveraged this by observing the light from a background galaxy in the Cosmic Horseshoe system as it traveled past the foreground galaxy containing this black hole. The light was bent and magnified, an effect known as gravitational lensing.
The Cosmic Horseshoe system is actually famous for this. The alignment is so perfect that the warped background galaxy appears as almost a perfect ring around the foreground galaxy, creating what's called an Einstein ring. In this case, it's more of an Einstein horseshoe.
So by combining those gravitational lensing measurements with observations of stars in the foreground galaxy zipping around at incredibly high speeds, almost 400 kilometers per second, the researchers had the concrete evidence they needed.
As Carlos Mello, the study's lead author, highlighted, this detection relied purely on the black hole's immense gravitational pull. It's a game changer because this method allows them to find and measure these hidden, ultramassive black holes across the universe, even when they are completely silent.
It's like being able to find something that's been hiding in plain sight. Looking ahead, this discovery could help us understand the critical link between galaxy size and supermassive black hole size. The cosmic horseshoe is what's known as a fossil group, essentially the final stage of massive gravitationally bound structures.
Meaning it's a galaxy that has absorbed its companions into one massive structure. It gives us a potential peek into our own realm's distant future, as our Milky Way and the Andromeda Galaxy are likely on a path to collide someday and might form a fossil group themselves.
It's truly remarkable. Thomas Collette suggests that all the supermassive black holes from the original companion galaxies in the cosmic horseshoe have probably merged to form this single ultramassive black hole. So, in a way, we're witnessing the culmination of both galaxy and black hole formation right there. The team's paper on this was published in the journal Monthly Notices of the Royal Astronomical Society.
From the mind-bending scale of black holes, let's turn our attention to some exciting developments much closer to home, specifically involving Mars. There's been a groundbreaking agreement announced this week.
That's right, Anna. The Italian Space Agency, or ASI, has just signed a deal with SpaceX for an uncrewed mission to Mars, utilizing one of SpaceX's Starship rockets. This is a pretty significant step for international collaboration in private space exploration.
It certainly is. Announced on August 7th, this agreement includes provisions for several important scientific payloads. We're talking about a plant growth experiment, a radiation sensor, and even a meteorological monitoring station.
And the Italians are ambitious about the data they'll collect. ASI expects to gather information not just during the 6-month journey to Mars, but also continuously throughout the mission's time on the Martian surface. ASI President Teodoro Valente even declared that Italy is going to Mars on social media, describing it as a first-of-its-kind agreement.
SpaceX's COO, Gwynne Shotwell, echoed that excitement, saying, "Get on board, we are going to Mars." SpaceX is now offering Starship services to the Red Planet. It's definitely a bold statement, considering Starship hasn't even launched any commercial payloads to orbit yet, let alone to another planet.
True, the development of Starship is still very much ongoing with those full-scale prototype tests. Elon Musk himself targeted the end of next year, 2026, for Starship's first mission to Mars. It'll be fascinating to see if they can hit that ambitious timeline.
And it's worth noting that this deal with SpaceX bypasses the European Space Agency. However, Italy has historically played a major role in ESA's own efforts to explore Mars. They're the largest contributor to ESA's ExoMars mission, for example, which is targeting a 2028 launch for its Rosalind Franklin rover. Shifting gears from Martian aspirations, we're now going to delve into a concept that truly pushes the boundaries of human ambition: a multi-generational starship designed to carry thousands of people on a 4-century voyage to another star system. It sounds like science fiction, but this is a serious design proposal called Chrysalis.
That's right, Anna. This isn't just a fantasy. Chrysalis is an award-winning design from an Italian team that secured the Project Hyperion design competition run by the Initiative for Interstellar Studies. The challenge was to create a realistic multi-generational ship using current or near-future technology capable of reaching another star.
And what a design it is. The concept envisions a massive rotating cylinder, more than 58 kilometers long, weighing an astonishing 2.4 billion metric tons. The rotation is key because it would create artificial gravity, combating the muscle and bone loss that occurs in zero-G. The jury praised its, quote, system-level coherence and innovative design of the modular habitat structure.
It's like a cosmic Russian nesting doll with layers built around a central core. Each shell would have a specific function. The outermost layer would act as a shield against micrometeoroids and radiation, while also serving as a giant warehouse for tools, spare parts, and raw materials, all managed by robotic systems.
Moving inward, the next shell would house industrial facilities for recycling, manufacturing, and even pharmaceutical labs. Closer still are the housing blocks, designed with comfort in mind. followed by communal spaces like parks, schools, libraries, and hospitals. And nearest to the core, we have the crucial food production areas, maintaining entire ecosystems with plants, fungi, microbes, insects, and even livestock.
And at the very heart of Chrysalis, the core would hold communication systems and shuttles for ferrying passengers down to the surface of Proxima B once the epic journey finally ends. Proxima B, for context, is 4.24 light years away, or about 39 trillion kilometers.
The ship is designed to travel at 1/10 the speed of light, which would still mean roughly 400 years to reach its destination. This includes a year for acceleration at the start and another for deceleration before arrival. For propulsion, they're looking at a direct fusion drive using helium and deuterium isotopes. While this technology is untested, it holds the promise of generating both thrust and electrical power.
A journey of this magnitude also brings up incredible societal challenges. The first generation of passengers would undergo 70 to 80 years of training in an isolated Antarctic habitat, testing their ability to live in close quarters and maintain psychological health. Birth rates would be carefully controlled to keep the population at around 1,500 people, even though the ship could hold up to 2,400, ensuring sufficient resources.
Governance would be a fascinating blend of human decision makers and artificial intelligence designed to strengthen social resilience and ensure knowledge transfer across generations. And for a unique experience, the ship features a cosmodome at the front, offering a microgravity zone with sweeping views of deep space.
It's a concept that truly makes you think about the when, not if, of interstellar migration. While nuclear fusion drives and century-spanning governance systems are still works in progress, projects like Chrysalis push the boundaries of what's possible, influencing future spacecraft architecture, life support systems, and long-duration mission planning right here on Earth.
From ambitious interstellar journeys, let's bring it back to Earth for a moment, or rather to Earth's launch pads. We've got an important update from ULA, or United Launch Alliance, regarding their Vulcan rocket, which is poised for a significant milestone.
That's right, Anna. ULA's 202-foot-tall Vulcan rocket is about to embark on its inaugural national security mission, USSF-106, as early as Tuesday, August 12th. This is a huge moment for ULA, as it's the first post-certification flight for Vulcan, and a mission they designed the rocket specifically to do.
Tori Bruno, ULA's president and CEO, highlighted just how critical this launch is, calling it the anchor case that drove the design and the architecture of the whole rocket. It's a particularly challenging mission, involving a direct injection to geosynchronous orbit, which makes it one of their longest duration missions ever.
And it hasn't been an easy road. This launch was actually hoped for much earlier, but faced setbacks, including a solid rocket motor anomaly during a certification flight last year, delays with Sierra Space's Dream Chaser, and even issues with the USSF-106 payloads themselves.
Despite those hurdles, ULA is now confident and ready to ramp up their launch cadence. Bruno revealed plans for 9 more missions before the end of the year, a mix of commercial and government flights. Some will still utilize their reliable Atlas V rockets.
He emphasized that they have a stockpile of both Atlases and Vulcans fully built, ready to fly, which gives them high confidence in meeting their goals. There are 13 Atlas V rockets remaining, with 7 allocated to Amazon's Project Cooper, 6 for Boeing's CST-100 Starliner, and 1 for Viasat.
ULA's ambitious target is to achieve a cadence of 2 launches per month by the end of the year and maintain that pace into 2026 and beyond. This is a clear signal that the Vulcan is ready to take its place as a workhorse in the launch industry, especially for those challenging national security missions that require such precise and long-duration orbital insertions.
They're also expanding their infrastructure, with Space Launch Complex 3 at Vandenberg Space Force Base nearly 76% complete and aiming for certification by the end of the year. And at Cape Canaveral, their second vertical integration facility, VIF-A, which will handle commercial Vulcan launches, is almost finished. It sounds like ULA is truly set to expand their presence in the launch landscape.
Speaking of expanding operations, ULA isn't the only one making big moves at the Cape. SpaceX is also pushing forward with its Starship Super Heavy rocket operations. And this is creating some significant discussions around launch capacity and environmental impact.
Absolutely, Anna. The Federal Aviation Administration, or FAA, recently published a draft environmental impact statement for SpaceX's proposal to launch up to 44 times from Launch Complex 39A using Starship. This includes plans for up to 88 landings of the first and second stages, plus static fire tests.
This is huge because Starship is, as Tori Bruno from ULA puts it, not just another rocket on the range. It's of unprecedented size and aims for a very, very high launch rate. Its operations will require massive clearance across the Florida spaceport, impacting other launch complexes like 39B and SLC-41.
Indeed. The Department of the Air Force is also considering SpaceX's separate proposal for up to 76 launches and 152 landings at SLC-37. Bruno emphasized that the Space Force and the FAA need to conduct a very thorough analysis of how this will affect not just the ecological environment, but also the overall launch environment for everyone operating there.
It's a complex situation. When one vehicle is fueled, certain operations are restricted on other pads due to the energetics involved. Given Starship's size, which is even larger than a Saturn V, it's something truly new to the range.
Exactly. The goal is for the range to maintain its capacity for all users. The public comment period for the SLC-37 proposal is closed, with the Air Force sifting through feedback for a final analysis. Meanwhile, the FAA is collecting public thoughts on the LC-39A proposal through late August and early September. It's clear that careful planning is essential to ensure everyone can operate safely and efficiently at Cape Canaveral.
Well, what a jam-packed episode of Astronomy Daily today. From the mind-boggling scale of that 36 billion solar mass black hole measured using Einstein's relativity,
to Italy's ambitious plans to send a Starship mission to Mars, pushing the boundaries of interplanetary exploration.
and we can't forget ULA's aggressive plans to ramp up their Vulcan launches, and the intense discussions surrounding how Starship's massive operations will affect the busy launch schedule at Cape Canaveral.
It really shows the incredible breadth of activity happening in space right now, from the deepest reaches of the cosmos to the very rockets lifting off from our planet.
It's truly an exciting time to be looking up. Thanks for joining us for another episode of Astronomy Daily. Remember to visit our website at astronomydaily.io if you'd like to listen to all our back episodes and achieve completionist status, or simply catch up on the latest space news.
We hope you enjoyed diving into these fascinating updates with us. Be sure to tune in tomorrow for more space and astronomy news. Goodbye for now.